In this presentation, I want to introduce you to a project that I developed for my college algebra students towards the beginning of the semester. In this project, students compare the total cost of two different insurance plans as the amount of medical charges increases. This project arose from an analysis I made of the two family plans offered by my own college. These two plans have very different premiums as well as different levels of coinsurance, copays, and deductibles. The Premier plan offers better coverage, but at a cost of $514 per month. The Basic Plus plan offers slightly less coverage, but at a monthly premium of $46. The out-of-pocket maximum for the Basic Plus plan is double that of the Premier plan. However, you pay 10 times more per month for that difference. My goal was to decide which of these plans I should choose. I wanted to pick the plan with the lowest total annual cost, assuming several visits to my doctor and a specialist. The visits to my primary care physicians incur a charge of $100, and the visit to a specialist incurs a charge of $150. I will also assume a single generic prescription that is charged at a rate of $30 per month. To model the charges and costs in each plan, I'll make a table of values with the column headings shown here. The first column will be my independent variable that I will increase in a systematic way. The total medical charges are what the medical provider charges if you're not covered by insurance. The total medical cost is the corresponding amount that the insured party actually pays for those services. The prescription cost is what the insured party pays for a prescription under the plan. The sum of those costs is the total out-of-pocket. This is what the insured party must pay in addition to the monthly premiums. Finally, the total annual cost is the sum of the total out-of-pocket and the premiums. We'll start this table with the smallest amount of medical charges that would be possible, assuming the 3 visits to providers. The visits would be charged at $350. We'll also include 2 other charges on our way to charges equal to $1,200, where the deductible is met. Since the Basic Plus plan does not split these charges until the deductible is met, the insured party must pay for all these charges. The generic prescription is charged at $30 per month. However, the cost is $10 per month with no deductibles, so the annual prescription cost is $120. If we add these amounts together, we get the total out-of-pocket at the different levels of charges. For the Basic Plus plan, the monthly premium is $46 for an annual total of $552. By adding the total out-of-pocket to the premium for the year, we get the total annual cost of the Basic Plus plan for several charges before and up to when the deductible is met. As expected, as the charges increase, the total annual cost also increases. Now let's examine the charges that are incurred after the deductible is met. So we'll start at $1,200 and increase the charges in each row of the table. The corresponding costs are calculated using the fact that the insured is splitting the charges with the plan on a 60-40 basis. This means that the insured pays 40% of the charges above the deductible and the plan covers 60%. For instance, let's examine the amount paid by the insured when there are $6,200 in medical charges. At this level, the insured pays the deductible plus 40% of the charges above $1,200. This amounts to $3,200. The other entries in the column are calculated in a similar manner. Once we have these costs, we fill in the rest of this section of the table as before. However, notice that the out-of-pocket maximum of $12,000 is exceeded in the last row. We need to know the exact amount of medical charges at which the total out-of-pocket is exactly $12,000. To find this, we solve an equation corresponding to the deductible plus the coinsurance plus the prescription costs set equal to $12,000. The solution to this equation is X equal $27,900. If we change the last row to correspond to $27,900 in medical charges, the total medical cost is $11,800. For this amount of charges, the total annual cost is $12,552. For any amount of charges above $27,900, the total out-of-pocket is $12,000 and the total annual cost is $12,552. If we graph the total annual cost as a function of the total medical charges, we see three line segments. The first segment corresponds to charges where the plan deductible has not been met. The middle segment corresponds to charges after the deductible is met, but before the out-of-pocket maximum is reached. The last segment matches the charges after the out-of-pocket maximum is reached. To find the piecewise linear function for this graph, we'll use the slope-intercept form of a line with x representing the total medical charges and y representing the total annual cost. The slope of the first line segment is found by using 2 points from this section. Once we have the slope, we can use it to find the y-intercept of that section of the graph. This gives us the line y equal to x plus 672 for x values from 350 to 1200. We'll use 2 points from the next segment to get a slope of 0.4. The equation of this segment is y equal to 0.4x plus 1,392. This segment is valid for charges greater than 1,200 and less than or equal to 27,900. The total annual cost in the last segment is constant. This yields the line y equal to 12,552 for charges greater than 27,900. The piecewise linear function corresponding to these segments reveals an interesting fact. The slope of each segment is the percentage of charges the insured party pays. Before the deductible is met, 100%, a slope equal to 1, of the charges is paid. After the deductible is met, but before the out-of-pocket max is reached, the insured party pays 40%, slope equals 0.4, of the charges. Once the out-of-pocket max is exceeded, the insured party pays 0%, slope equals 0, of the medical charges. Plans with copays are handled a bit differently. In the Premier plan, there is a $20 copay for office visits to the primary care physician with no deductible. Additionally, specialist visits require 20% coinsurance. So the 2 office visits and 1 specialist visit will cost $70. The deductible is reached once an additional $600 in charges are attained beyond the visit charges. The insured party pays all those additional charges. Using 2 points from this table, we can find the slope and the y-intercept of the line. Before the deductible is met, the equation of the line segment is y equal to x plus 6,008. This segment is valid for charges from $350 to $950. Once the coinsurance kicks in, the total medical cost is calculated by adding the deductible, the cost of the visits, and the 20% coinsurance of all charges above the deductible and office charges. As before, the total out-of-pocket maximum is exceeded for some charge. To determine the charge at which this occurs, form an equation with the out-of-pocket maximum of $6,000 on one side and the total medical cost plus the prescription cost on the other side. The solution to this equation is the charge X equal to $27,000. Putting this into the last row of the table gives us the point at which the out-of-pocket maximum is reached. Now we can use 2 points in the table to determine the equation of this line segment. This segment's equation is y equal to 0.2x plus 6,768 and is valid for charges above $950 and less than or equal to $27,000. Note that we could have used any pair of points to find this line. Since the function is continuous, it's not crucial to use charges that are strictly in the region. The charges on the border work just as well. The total annual cost in the last segment is constant. The equation of this line segment is y equal to 12,168. This equation is valid for charges greater than $27,000. As before, the slopes on this piecewise linear function correspond to the percent of the charges the insured party is responsible for. Graphing these functions together gives us a complete picture of the two plans. The point of intersection gives us a level of medical charges where the total annual medical cost is equal. This occurs in the second segment for each plan. Setting these functions for these segments equal gives us a charge of $26,880. If the amount of medical charges is less than $26,880, the Basic Plus plan will be the cheapest. If the amount of medical charges is greater than $26,880, then the Premier plan is cheapest. However, keep in mind that there's only a small difference between the plans once the amount of charges exceeds $26,880. To get students to carry out this process, I use several technology assignments to help them organize the information in the plans. Excel is the logical choice for doing this. The first technology assignment introduces them to the idea of a spreadsheet and teaches them how cells are named as well as how to format individual cells, rows, and columns. However, I don't want them to simply duplicate what I have done for the Basic Plus plan and the Premier plan. I want them to work with two plans of their own choosing. They can locate two plans customized to them at the website ehealthinsurance.com. They start by putting in their zip code into the web page. Then they put in their information for individual coverage or their information and that of their dependents if they are interested in family coverage. This website requires applicants to be at least 19, so I ask them to adjust their age if they are not 19. Once they click Go, they will be given a large number of plans to choose from. I ask them to select one high deductible plan and a low deductible plan. I also urge them to select plans with different coinsurance requirements. This ensures the graphs of the two plans cross. When they compare the plans, they'll be able to see side by side how the coverage compares. They can use this information to create an Excel worksheet with the plan details. In the next technology assignment, they use the plan details to create tables of values like the ones I showed earlier. This is usually the most challenging part for students. Most of them have never even thought about any type of insurance, so many of the concepts are completely foreign to them. One possible option is to have them fill out a table like I showed before as an in-class activity, and then have them put the values into Excel. I emphasize using features in Excel like fills and cell references so that the worksheet does the work for them and they can verify any information they calculated by hand. In the third technology assignment, they learned how to graph the columns in the worksheet. I have them do this on two separate graphs since it's easier than trying to put the graphs all together at once. In the fourth technology assignment, they put the graphs together, find the piecewise functions, and locate the point of intersection. You can end this project by having them write a paragraph or so on which plan they would choose and why. I like to have them put together a formal document explaining the process they went through. I call this document a technical memo. It consists of 4 sections. In the first section, the introduction, they explain what the problem is, the data they used, and any assumptions they made and what they will prove. The second section is the methods section. In this section, they define all terms, like deductible and coinsurance, used in the project, as well as any variables and functions they will utilize. Explaining the relationship between the different quantities, like total medical charge and total medical cost, is also required. If they have any procedures, like finding the equation of a line from 2 points, they need to talk about the procedure in this section. In the results section, they carry out the strategy outlined in the methods section. Students have a tendency to want to write a solid mass of equations without any explanation. Getting them to use sentences in mathematics is like pulling teeth. For this project, ending the results sections with a comparison graph is a good ending point. This allows them to use the discussion section to explain what plan should be chosen and why. I also ask them to look at the big picture and talk about that too. I grade the technical memo in 5 areas, each on a 7-point scale. I use a rubric in each area. They can earn a total of 35 points. Since this is the first time any of the students have written a document like this, I don't expect that they'll be able to get a perfect score. I take their score out of 20 or 25 points, with any additional points being extra credit. On later projects, I raise this maximum until the max is 35 points on the last project. Extra credit is at the beginning of the semester instead of at the end. This accomplishes 2 things. First, it gets them working hard at the beginning of the semester. The better they do on this project, the better they will do on later projects. Second, many students will have a very high score on the first project. Because of this, they're highly motivated for the rest of the semester. If you'd like more information on this and other projects, check out my website, pblpathways.com. You'll find some actual technical memos written by students, the handouts used in the technology assignments, videos I use in conjunction with technology assignments, as well as 23 more projects. If you're interested, you can also check out the blog I maintain for my students at ycmath.com.